Hello, in this video we're going to look a little bit at Excel and statistical functions that are built in Excel. Now Excel, of course, is the leading spreadsheet put out by Microsoft, and it's a very good tool for doing lots of different things, and this video is definitely not going to touch on very much of that, but I just want to show you that there are some statistical functions that are built in, and I want you to show you this little thing that's got this f sub x, which is a function wizard basically. And so if you click on that insert function, you get this little dialog box that comes up. And if you'll go to there's some different things. There are financial functions, date and time, trig functions, and math functions, different things. But if you'll click on statistical, this gives us a list of a bunch of statistical functions and that we can use. Let me actually just put let me just put a real small data set in there. And I can actually go here and look at a couple of different functions. Some will use a data set, some won't. So for example, this average AVEDEV returns the average of the absolute deviation. So that's what we were calling the mean absolute deviation, or MAD. And so I can click on that and it brings up this little wizard and it sort of tells you what to put in. So here I can go and give it a range here, and it gives us the mean absolute deviation of that data set. Pretty cool, huh? Okay. We can also look at some other functions. For example, average is the mean. So I can click on that and I can give this here, and it does the mean of that. Let me check one more thing real fast. On the average, okay, and we can have different ranges of numbers there with it. Okay. Okay, now what else can we look at? Well, let's see. So that's some basic ones. Now there's some other things that with the average or mean, and there are some variations on a theme that you can give it some conditions and things, some more fancy things there. The beta distribution is a type of distribution. The binomial distribution, look at that. This is the binomial distribution. So let's look at this here. And here's the data that the parameters that we enter in. So the number S is the number of successes in the trial. So let's say we want to find the probability that X equals 5 from a binomial where the number of trials or sample size is, say, 25. The probability of the success each time is 0.3. And then you have a choice here, true or false, for cumulative. And see, if you look down here, it kind of tells you. So, for example, if you click on this, the number of successes in the trials, it tells you that. Trials is the number of independent trials, the sample size. This tells you the probability of success on each trial. Cumulative is a true-false. If you want it to be the cumulative distribution, use true. If you want the probability mass function or probability density function, the PDF or PMF, that's false. So if I do false, this will give me the PDF there of that particular one. If I go over here and do the same thing, let's just copy and paste it, but change it from false to true, that gives us the CDF. So that's the cumulative there. So that's built. So binomial PDF, CDF is built in. Most of these, the true false at the end makes it a CDF or PDF. There's an inverse binomial right here. We wrote a program for that on our calculator. It will return inverse binomial. It gives us the first one for which the cumulative is greater than or equal to the criterion value. So I can say, again, let's say 25 trials. The probability of success each time is 0.3, and the alpha value is the probability. And let's say 0.9, we get 10. So what that should say is if I do, let me see if I remember what I put in there, 25.3. Okay, so that means if I go back here and do a binomial distribution and do 10 here with 25 trials, and the probability success is 0.3, and for cumulative I put true, we should get a probability for the first time that it's greater than 0.9. If I'd done this same thing here and switched this to 9, now you're going to see that it's actually less than 0.9. So it's the first time first one to exceed that. So that's exactly what we want for an inverse binomial, and it's already all built in there. Chi-square are some things that we're going to be doing later. It does have a chi-square distribution and an inverse chi-square. We'll do that later on in our next unit. F is another one we'll do in our next unit. Some of these are others. Some of these are things that I'm not covering in my class, but there are other other things we'll do here. There's a maximum and a median. There's median, so I can do median of this data right here, and that will be the median of that particular data set. So that works out nicely. I can, of course, I could put labels out here by the side or something if I wanted to. I'm just kind of showing you some of the things that are built in. Here's permutations, the number and the number that we're choosing from, like say 25 permute 3. That's going to be that. That's how we get that permutation. Let's see if a combination is up here or if it's okay. It's probably, I'm not sure where it is. We'll have to look that one up. Okay, let's see. Normal is a very important one that we'll do later on. Negative binomial is one I have some data about here a little bit later video, but I don't usually cover that in my course. Let's see, quartiles. You can find quartiles from here. Skewness, we'll do that. Standard deviation, if it's a population or if it's a sample. T is an important distribution we'll study later. Variance, it will figure out there, and so forth. So let's see. Geometric is another one we're doing. Let's see if we can find that one. There that's a geometric mean. I don't see a geometric, but I do see a hypergeometric. So there's a hypergeometric. This is the number of successes in the sample. Let's say we might find the probability of 6 successes in a sample of size 20, where the population is size 100, and there are 68 successes in the population. And again, I can do, if I do false, that's going to give us the CDF. Whoops, did I do something? I may have put this in the sample. I've got something in the wrong order here. Let me try that again. Hypergeometric. There it is, hypergeometric distribution. Okay, number of successes in the sample. Okay, let's say 6 there. The size of the sample, it needs to be bigger than 6. 6 or bigger, so let's say a sample size 20. The population, successes in the population, and then the number, I think I got those backwards a while ago. Successes in the population, let's say there's 68, and a population of size 100, let's say, and then do false here. And there we go, very, very small there. But if I go up here and make this, that's the probability that it actually equals 6 in that particular distribution. If I do true, that's going to be the cumulative probability, that's probability that's less than or equal to 6 for the random variable. Let's see, are there any others that we've done? What about Poisson? There it is, Poisson. Okay, you give it x. Say what's the probability that x is 6 when the mean, and they actually call it the mean here, which is called mu by me, or lambda by a lot of folks. So the mean is 10. And again, you can do a cumulative or not. I'm going to do false, at least to start with, and that's the probability that x actually equals 6. If I did true, again, that's going to be cumulative, and that's going to be the probability that x is less than or equal to whatever it was I put in, 6, I believe. I don't see a geometric. So you'd have to work that out a little bit differently, geometric distribution. But other than that, it has a lot of the main distributions we've been dealing with, and some that we'll be dealing with later. So I just wanted to show you, you can look there for different probabilities, even inverse probabilities for some of these things that we didn't have in our calculator are built in here as well. And so you can use this to build up some things. Now, in the next video, I've got a huge spreadsheet that I've worked up with a page for each of the standard kinds of distributions talking about it. And you can see some more of that in the next video. And of course, I'm using some of these kinds of functions in building that spreadsheet.